that we can start. As we are admitting our attendees, let me welcome everyone who is joining and watching us. We are back for our sixth and final webinar for our project Fruit Flies in Silico Prevention and Management under the Horizon 2020 European Funding for Research and Innovation. Reflecting back to this journey, from our first webinar to this one that is going to be our last, I think we had a great chance to communicate through these webinars the progress that was implemented in our project that is now coming to its end. Please let me share that this webinar is being recorded and we will use it for the dissemination actions of the project even after its closure. Please note that after our speaker finalizes her speech, we will have some time for some questions. So please use the Q&A button at the bottom of your Zoom screen in order to address any questions. And we can take some time to have your replies. I don't want to burden us with more. I think we can start. I will ask our moderator, project coordinator, Professor Nikos Papadopoulos, from the Department of Agriculture, Crop Production and Rural Environment from University of Thessaly, to briefly introduce us to the topic and to our speaker. Professor Papadopoulos, thank you very much, and the floor is yours.
Thank you, Georgia. So hello to everybody. Good morning, good afternoon. I don't know from which place of the globe you are attending. So as Georgia mentioned, this is a long journey for the project and for the webinars as well, that we managed to conclude almost 4.5 years in this project. And also we had a series of prominent seminars, and we continue with the last one. So I'm really happy today to welcome Anna Sinisevska and to present Anna Sinisevska, who is our speaker. And Anna is currently working at the CABI as a technical leader of the global burden of crop losses. And Anna has quite a long experience, although she's still very young, on dealing with geography, spatial analysis, crop modeling, and focusing on pest losses. And she has a really long experience on modeling fruit flies. So the talk of Anna today is on fruit flies pre-border risk, and trying to link the pathways of climate suitability for fruit flies. I think this is a really important topic, and we are all looking forward to listen to Anna's talk. So Anna, the floor is yours.
Thank you, Nikos, and thank you, Georgia, for the introduction and invitation to the seminar. I will share my screen. Right, so again, hello everyone. My name is Anna Sinisevska, and today I'm representing Corvus Geostat in Poland. I thank you for the opportunity to give a seminar today and present work done in collaboration with my colleagues, Hania, Karol, and Darren Kritikos, on assessing the pre-border risk of fruit fly importation to Europe. I will be discussing our approach in linking commodity pathways analysis and climate suitability models information to achieve this. And for those who may not be very familiar with FF-IPM, it's a European research project funded to protect fruit production in Europe, so from the trade threats posed by importation of fruit flies. And the objective of the project is to establish in silico supported prevention, detection, and integrated pest management approaches for 3 fruit flies currently established or at risk of introduction and establishment in Europe. And over the course of the last over 4 years, the project built a wealth of new knowledge to fill many knowledge gaps related to fruit fly biological traits and socioeconomics. And this work has fed into work on spatial modeling, population dynamics modeling, and designing real-time alerts and decision support systems on the project. And also part of the project was to explore what is happening in Europe and worldwide as part of global change, changing climate and changing transport flow, volume. And we looked at how does it affect and shape the risk of fruit flies importation to Europe. And the work that I've been involved in was to support the development of this complex decision support and alert system. The intention of this system is to provide tools to support important decisions in each of 3 big domains that make up the biosecurity continuum, which is the pre-border, border, and post-border activities. And the system is not intended to make decision, but rather it's intended to support decision-making and to provide system alerts when certain conditions have been met. For example, if there is a new fruit fly detection in Europe. There are many data products embedded in the system, and at the heart of the system are models that support efficient surveillance, post-border and also pre-border. In the context of the work that I was doing on the project related to fruit fly modeling, and that included climate niche modeling, but also population dynamics modeling and examining the trade flows, like an overarching theme of this work is really a global change. And it's an ongoing challenge when it comes to addressing the risk of invasive pests, because we are dealing with a highly dynamic and changing risk. The faster transport pathways, they facilitate incursions of pests via infested fruits, and thus they create opportunities for new establishments. And we know that the suitability for pests at the origin location, it's changing. And it's also changing the conditions of like facilitating the potential establishment of pests at the destinations may be changing. And we know that this may work in their favor. Another aspect that is facilitating the increasing risk of pest invasion is also the proliferation of irrigation in drier climates that create conditions for new source areas and establishment of tropical pests, which then further may increase the chance of pest importation and into Europe. So something that we hypothesized in our work is that the risk of the fruit flies importation to Europe is changing in time. So it's changing over the course of the years, but also seasonally within a year. And this little video here represents a climatic suitability model for one of the fruit flies, which is showing the weekly growth index values, which means the values which indicate that the climate at a particular location is suitable for fruit fly population development. And this conditions, they change. It's a weekly illustration of weekly changes in the suitability risk. So we, at the heart of the hypothesis and analysis is the assumption that the risk of fruit fly importation will changing on a seasonal scale. So some of the questions we've been asking in this work is really which agricultural consignments should be prioritized for inspections? Do all consignments, will they all be at the equal risk, or maybe we have an opportunity to prioritize them depending on where they're coming from, when they are coming from, and what kind of commodities they are. And also, which ships then should we inspect at different times of year to guard against the spread of high-profile pests at the port of entry? So the objectives of this work was to understand the changing risk of fruit fly importation to Europe by analysis of the historical patterns of fruit fly interceptions in chosen European countries, and understanding the seasonality of transport and also interannual trends in commodity flows, and linking transport data to climatic suitability models and their outcomes at the source where the commodities are being loaded. The data sources that we reviewed a number of candidate sources for trade data, including TradeMap, UN Comtrade, and Eurostat COMEX. So the data sets were compared for their comprehensiveness, detail of information, and the ease of access. We also reviewed the past about 20 years of interception data of harmful organisms in Europe from the Santa Traces database, which is formerly was gathered by Eurofit. We matched the commodities as classified by the World Trade Organizations with the information from EPO and Kabi Crop Protection Compendia. So we looked at which hosts are associated with fruit flies and identified the codes from the WTO database that could be matched and be associated with commodities that can potentially be hosts to the 3 fruit flies of interest. In results, we had 39 commodity codes identified that we used for the analysis. And at the end of the presentation, I will also discuss work on modeling the climatic suitability for the 3 fruit flies of interest. They were built and updated from the existing models to represent the population dynamics of fruit flies at the source locations. They were updated with the knowledge of new occurrence information at the margins of the suitabilities. So in the following couple of slides, I will review the main patterns of the fruit fly interceptions in Europe that we observed. The data from the Santa Traces system is available for the previous month. It's very comprehensive. We know what was the origin location of the commodity in which the interception was found, and we also know what was the destination as well as the date of the detection at the border. However, we could not identify exactly the port or location where the interception has occurred. So we queried the Santa Traces database by the following groups of organisms. So they were either at the level of Tephritide or the genus level Bactrocera or Ceratitis. Very few records were recorded at species level. For example, Bactrocera dorsalis, Ceratitis capitata, or Bactrocera zonata. So the largest proportions of the interception data was at the Tephritide level. Amongst all of these interceptions, we looked at which were the commodities that were associated, on which these interceptions were found, with the top one being mango, following by a couple of other commodities, including guava, bitter melon, capsicum. We have mapped the origin locations of the intercepted fruit flies. Many of them came from South and Southeast Asia. Also, many interceptions were associated with West and East African countries and also Caribbean. And regarding the mode of transportation and locations where the interceptions over the last about 20 years were found, the majority of interceptions were recorded in the United Kingdom, France, and Netherlands. Obviously, the most recent Santa Traces data is not containing information from the United Kingdom. And so overall, in recent years, the number of interceptions has overall, because of that factor, decreased. But the main mode of transportation on which these interceptions were found was transport and also sea and passenger luggage in fewer cases. Looking at the dates of when the interceptions occurred, we observed highly seasonal patterns, with majority of interceptions being observed in the summer months. And this plot represents, by colors illustrates the types of organisms associated with these interceptions. The decrease over the couple of last years is associated with less records, removal of records from the United Kingdom. This plot represents the overall interceptions rates in terms of seasonality when we aggregate data from the last about 20 years, and we looked at the number of interceptions per 10,000 tons of imported commodities. This is the seasonal pattern that I mentioned earlier, as well as looking at the aggregation of commodities. We also observe seasonal patterns in when the commodities are arriving, but I will be showing it in more detail and more commodity specific in a moment. The biggest number of interceptions per 10,000 tons by world regions was observed from South Asia, following by East Asia and Pacific and Sub-Saharan Africa. And now I will present a couple of results of our analysis of the trade data. And the exploration of trade data was very comprehensive, and I will show just a couple of results in this presentation. As mentioned earlier, at the beginning, we identified the commodity codes that could be associated with fruit fly interceptions, and our assumption was that we were reviewing what kind of plants are included in each code and whether these plants are classified as hosts to either of these three fruit flies by EPPO and CABI databases. Often these codes will encompass more commodities that we think might be at risk. For example, they may include dried plants that we would be less suspicious of. However, it's impossible from the data as it is collected to disentangle exactly the proportion of commodities that could be at risk. As we could see in the interception data, guavas and mangoes were commodities that were frequently associated with fruit fly interceptions. So we looked at the quantity of imports of these commodities to European countries in 2016 to 2019. Even though we had access to long records of the trade data, we decided to review only most recent years and embed them in the decision support tools because of the continued changes in fruit fly in commodity imports. So some of the top importers included Netherlands, Germany, United Kingdom, France, Spain, Portugal, and Belgium, and many of these goods will be further redistributed between European countries via transportation links. This plot represents the long-term trends in trade flows, and that elucidates to my comments from the previous slides why we decided to look at the shorter time frame and embed it in the decision support tool. It's because of the longer-term changes in trade flows, which overall, from our analysis, indicated that are increasing, although the last couple of years has slightly made this picture more complex. So the decision support system is reviewing information for the 39 selected commodities and the seasonality of the importation of these commodities to Europe. It's country specific, so each country will have a little bit different picture when it comes to the importation of commodities, obviously. But this is one example of the monthly imports of dried or fresh oranges from South Africa to all member states in Europe, where we can see that the imports commence in about May and they last until December. When it comes, for example, of the imports of oranges, however, from other origin locations, and here we have on the right-hand side a picture from Spain, this seasonal trend will be very different. However, the seasonality is just to emphasize how strong effect of seasonality there is. So not only seasonally, but also by year, this picture will be changing. And this plot is showing the annual exports of fresh or dried oranges to selected European countries from different countries, including South Africa, Egypt, and Morocco. So while we can see like largely similar trend over the years, this is still changing on annual basis as well. And now moving on into climate suitability work, we have utilized 3 climate suitability models for each individual fruit fly, so med fly, oriental fruit fly, and beach fruit fly. And we've done it by updating existing Climax models. So for those of you who are may not be familiar with Climax, Climax is a semi-mechanistic, hybrid, inductive and deductive model, which means that it can take biological information and embed it in the model structure, but it can also deduct information about the organism from occurrence location. And the assumption in this model is that in the course of a year, the populations of an organism may experience one or more seasons that are favorable for growth, and conversely, some seasons that may be stressful for the development of an organism, and during which the population of the organism will decline. So the model integrates weekly responses of a population to climate and calculates a set of climate suitability indices. And it requires information about the minimum and maximum thresholds for organism development, but also, so here on the top we have dV0, which would be the minimum temperature, and the dV3, which is the maximum temperature. But we also have this optimum threshold for an organism development at which we assume that the growth will be the fastest, so dV1 and dV2. Similar logic applies to the moisture index and limiting levels of moisture availability. So whether it's too dry for the development or too wet for the development, but also there is an assumption there will be a sweet spot and optimum for the organism development in between these values. Irrigation scenarios can be applied in the models, so the results I will be showing will be a results of two different models with and without irrigation. And the model is ecologically consistent in response to novel climate scenarios, so gives an opportunity to run climate change models and examine the potential responses of organisms to future climate. So I mentioned that Climax produces a set of indices. One of them is the growth index, which displays the favorability of the climate for species development. And this is something that we are embedding in our, later on in our analysis. It's a weekly index. But there is also an overall ecoclimatic index, which ranges from 0 to 100 and indicates whether or not the location is favorable for the long-term survival of the species. Where probably an EI of more than 30 represents a very favorable climate for species development, and 100 is really very difficult to achieve. There are also stress indices that Climax is calculating, like cold stress, dry stress, heat stress, and wet stress. And these indices will be working against the growth index, and if they exceed certain value, they will inhibit, the model will inhibit the possibility of the organism surviving in a particular location. So in order to update the models for Ceratitis capitata, Bactrocera dorsalis, and Bactrocera zonata, we have conducted very extensive literature review looking at the minimum temperatures, optimum temperatures, maximum temperatures, and other indicators of the biological response of the organism to environmental variables. And the updated Ceratitis capitata model was recently published, and we use the outcomes of this model in our analysis here. We also updated a model for Bactrocera dorsalis from a paper published in 2016. And we built a new model for Bactrocera zonata. And from each of these models, what we are looking at in real time is what is the weekly growth index value for a fruit fly in the origin location based on most recent climate data. So the model parameters are being applied on the live climate data information derived from EW, from the ERA5 climate data set. In the decision support system, the information can be browsed by species. So for each species in each week, in countries where we know the species is present, the system calculates the maximum growth index value in this particular week in a given country, filtered by cropland areas. So it's taking like a more conservative approach. So taking the highest value, and this growth index value will then serve as a component of a weight that will be applied to the volume of commodities that are being transported in order to give them higher or lower importance in terms of whether or not they could potentially be infested with fruit flies. So if the highest growth index value in a particular country is high, then these commodities will be ranked as potentially higher risk commodities. Whereas if this growth index has low value, and I apologize, I didn't include here a color scale, but the lighter yellow would indicate lower growth index value, then this commodity transport will be ranked as potentially lower risk. And this slide represents, like outlines this logic where the maximum weekly growth index in each country is calculated, and this is done for the preceding week. And weekly weights related to volume of certain goods transported from countries where fruit fly presence are then calculated. And each week we generate a table of source countries which pose an elevated invasion threat from the fruit flies. So the trade volumes, I will be showing there is a sort of weekly scoreboard, and the trade volumes are standardized either by weekly, so showing in a particular week of all the commodities which ones are the highest risk, or it is can be looked at as an annual in the perspective of annual flows to see when in the season this risk will be higher. So we can either have weekly view or annual view of the risk. And in the decision support system, that's a screenshot showing these results like live by week. So it's showing different countries and imports to Europe, and the trade volume standardized according to, we can see that the top one is the highest volume of commodities in that particular week is coming from Israel, and these are commodities associated with that we selected as associated potentially with fruit flies. And we have the climatic risk indication, and also weekly and annualized risk calculation. And these tables can be sorted to see commodities from which locations are potentially at the highest risk. And these risks then can be browsed historically back in time, but also will be the tables will be showing the most current situation based on current data. So some final remarks. The pest risks are usually considered in terms of either the potential pest risk or a pathway, and the PRAs, they mostly involve a geographical picture of the destination risk, but the pathways and pre-border planning requires analysis of the source risks and the pathway analysis. We have seen, based on data, that these patterns in fruit fly interceptions vary through time, and also the patterns of trade varies through time and has very strong seasonal patterns. And also climate suitability for fruit flies at the origin locations will also have a very seasonal pattern. We were unable to link well the interception information with to validate the analysis, because there is a lack of systematic surveillance data that would enable us in better understanding of the key drivers of these risks. And it concludes my presentation, and I will be happy to take questions.
Great. Thank you very much, Anna. This was wonderful and very comprehensive. And also, I would like to add that this is a development with major importance for the interception for the different countries. And the tool that has been developed, I think, will be used in the future. It's really interesting to combine the trade data with the climatic modeling to bring the biology of the pest at the country of origin with all the, the movement of the fresh fruits. I think this is unique. So thank you again. So we have actually time for questions that can be placed in the questions and answers in the chat, and then we can bring them to the floor and ask Anna. So before going there and waiting for people probably to think a little bit and ask their questions, I would like to discuss something with Anna. So Anna, you have really comprehensively captured, let's say, and mapped the pathways of introduction of the different pests, let's say, because we have all the trading in the different ports of entry in Europe, and also with different means. We have by air, we have by sea, we have with different means. Is there any correlation between this information and the detection? So this is pre-border. What happens with the post-border, let's say, issue with fruit flies, and whether there is a correlation?
So we did observe a very strong correlation between the interception data and between the seasonality and the timing of the interceptions and the seasonal trends of the trade of the commodities associated potentially with fruit flies. So this correlation was very strong. It would be even better if we had like a more systematic approach, like maybe spatial approach in fruit fly detection. So in many countries, these detections were maybe not present, and we did not have a good understanding of how often the commodities are being inspected and whether this inspection is already prioritized or is representing really a random sample. So having like additional information with more random sample would enable us to have a better understanding of the key drivers of which are shaping that risk. However, based on interception information and the flow of goods, that correlation was very strong.
That's absolutely right, and I think your work is really highlights all this. But looking at Europe and looking at these tropical fruit flies, apparently we have a big gap there, which there are many assigned as Stephritidae. So, and we don't really know what's happened. So we have a small proportion that are identified to the genus level, but we have detections of dorsalis and zonata currently in Europe, and I don't know if I'm updated, but we have in Italy, in Napoli, we have in some parts in France, we have some recent in Belgium, and also for years in Austria. This is it in terms of detections. So what I can see, and you can correct me, that there is no a correlation between the interceptions and the detections. So this is a really interesting part of the story that we should try to understand, because these guys arrive with infested fruits. This is accepted, but then, you know, they don't pop up at the ports of entry. They pop up at different countries, so at different places. So
Yes, exactly. Whereas Italy and Austria, they come up in the interceptions, some other countries, but more notably northern countries have more interceptions, which we could argue have less suitability for fruit fly establishment. Interceptions come up in the countries you mentioned, but at much lower scale. So this another component of post-border is also very important, whether or not the interception happen in areas that can facilitate the fruit fly establishment.
okay, I cannot see much coming out from our questions and answers. I
No.
suppose for those attending that they can send a message directly to Anna, or they can communicate with us, and then we can try to give, let's say, an answer to
We
the
just had one
questions.
question. Sorry for the interruption.
Oh, there is a question. Excellent.
Yes, from Mr. De Meyer, but your interception is largely or solely based on interception of commercial shipments, but not from private travelers.
Yeah, it's a very good point. There was a study before in the United States which showed how, like, what a high risk passenger luggage can pose in terms of interceptions. Santa Teresa's database, some of the interceptions were associated with passenger luggage, but it doesn't seem that it's shedding a full picture because very few observations in that database are associated with private travelers. It's mostly cargo, however, not exclusively.
Good. Thanks, Anna. So I cannot see additional questions. So we can probably try to wrap this webinar, the last webinar of the FF-IPM project. As I said, that you can get in contact with Anna, or you can get in contact with us, and then we can discuss and bring Anna to give some additional answers. As I mentioned earlier, I've seen all this development as very relevant and important for European countries. And this is something that can be used for intensifying probably the interception activities seasonally, or, you know, there are different ways to use this information. And also this work is paving the way for additional studies and additional questions to answer, as I said before, linking the interceptions with the detections. Also the point that Mark raised on the individual, the travelers, and how this contribute to all this phenomena. So Anna, thank you very much, and thanks everybody for attending, and also for attending all these webinars. It was really pleasure to have you on board, and you can still go to our website and look at the past events, the past webinars, and also this one, as Georgia mentioned earlier, has been recorded and will be uploaded there. So thank you very much.
Thank you.
Thank you very much. Thank you, everyone. Thank you for these 4.5 years of this journey during our implementation. Everything of our progress, all the results will be uploaded, and of course, everyone can reach them further. Thank you very much.
Before closing, I would like just to say a few words for Georgia for coordinating all this activity. R&D, but especially Georgia. Georgia was really important on putting this together. So an upload for Georgia, and for our speaker, for Anna, of course.
Thank you. It was great. It was great having this with all of you.
Okay. Bye-bye.
Thank you. Goodbye.